Okay, for this week we are going to do roots and radicals, and you only have 1 week to complete the homework this time, just so that we get everything in the semester. Usually it's 2 weeks, except this one thing here. So we're going to simplify, and for this class we're only going to focus on square roots. So of course you've got cube roots and fourth roots and fifth roots and so on, but we're going to focus on square roots. And if you look at the notes that are topped, it tells you the radical rules, so I'm just going to kind of tell you as we go. So if you have the square root of y to the 8th, so you have your index here is understood to be a 2 if there's nothing there. And like I said, that's what we're going to focus on for this class. So just like with the square root of numbers, you want to know what times itself will give you your y to the 8th, or like if you were doing numbers, what times itself gives you that number. Same idea. So what times itself will give you y to the 8th? The way that I like to think about it is 2 divided into 8 is 4, so it's y to the 4th. And the reason is that y fourth squared, right, is 4 times 2 is 8, because if you take a power to a power, you multiply. Or you can think of it as y to the 4th times y to the 4th, whichever way you want to think about it, and then you add the exponents. Either way, you get y to the 8th. So for square roots, you just divide 2 into whatever the power is. So if it's even, it'll always come out, you won't have a radical left, but if it's odd, you'll always have 1 left on the inside, which we'll get to in just a minute. So for number 2, we have negative square root, and for square roots, you can't have a negative on the inside, but you can have a negative on the outside. So, and for all these, unless it specifically tells you to find the domain, or to state whatever to make it have a real number, so that it's a real number expression or something, then you're just going to assume that it's not imaginary, that it is a real number. So we have negative square root of 100 x to the 8th y to the 12th z squared. So we want to, the negative just stays, so it just kind of hangs out there. So like I said, negative in front's fine. The square root of 100, what times itself gives you 100? That would be 10. 10 times 10 is 100, so 10. X to the 8th, again, you can just think about it as division. 2 goes into 8 4 times, so that would be x to the 4th. Then you have, and sometimes I didn't cross them out on notes, but some people, when they do this, when it's kind of gets to be a longer thing, they'll like cross out, say, okay, I've already taken care of that. And then I've already taken care of that, and then keep going. If you want to do that, that's fine. Y to the 12th, 2 goes into 12 6 times. And then now we've taken care of that one. And z squared, 2 goes into 2 1 time, so z to the 1st for z. So, like I said, if you square this, so the negative's out front, so if you wanted to check this by squaring it, you would put parentheses around this and square all these. So you'd have, because the negative just stays out front, so you'd have 10 squared is 100, x to the 4th squared is x to the 8th, y to the 6th squared, 6 times 2 is 12, and z squared is just z squared. So now we've taken care of all of those. So this next section here, this is what I was saying. It says write the proper restrictions so that it is a real number. So like I said, unless it says to do this, or state the domain or something, you're just going to assume that they're all real numbers. So we are going to jump down to number 8, I think, yeah. So for number 8, we have 5 square root of 16 m to the 6th n to the 7th. Okay, so again, just like with the negative here, the 5 is just going to hang out there and get multiplied by any number or whatever. So you got 5 times something. The square root of 16, the square root of 16 is 4. 4 times 4 is 16. So I've taken care of this. The square root of m to the 6th, 2 goes into 6 3 times. And again, m cubed squared, m to the 3rd to the 2nd, 3 times 2 is 6. So that's why. So I've taken care of this. And then you have n to the 7th. So if you have an odd exponent, 2 does not go into 7 an even number of times. So what I do is usually write down n to the 6th times n. That's the same thing as n to the 7th. And then I can take this one out. So 2, it goes into 6 3 times. So I've got n cubed. So this is gone, but I still have this n left. So the square root of n stays there. So this is 5 times 4 is 20, and then I'm done. And like I said, or I didn't say it yet, but so this is just left inside. The square root of n is left. And it's the same idea as, just as an example, like if you want to simplify 45 and take out a perfect square, the perfect square in 45 is 9. Square root of 9 is 3, so that's 3 times, you've got, this is gone, the 5's still in there. So 3 square root of 5. So it's the same idea. You want to take out the perfect square. So the perfect square would be all even powers. So anytime you have an odd power, you're going to have a first exponent, whatever your variable is, to the first left inside. Okay. Now, if you have a fraction, or you want to be able to rationalize denominators. So to show you how to do this, so you want to clear out the denominator. You do not want to have a radical in the denominator. So right now it's written as the square root of 2 divided by 7. So you can split this. Radicals, when you're dividing or multiplying, can be split. You cannot do it with addition and subtraction. So the square root of AB is the square root of A times the square root of B. But you can't say the square root of A plus the square root of B is not the square root of AB. So it only works for multiplication and division. So like I said, if you look at those type tools, it tells you that. And then we want to get rid of this radical in the denominator. So what we're going to do is we're going to multiply the top and the bottom, because whatever you do to the denominator, you have to do to the numerator. So we're going to multiply both the top and the bottom by square root of 7. And the reason we do that is, I'll do the numerator in a minute, but the square root of 7 times the square root of 7, 7 times 7 is 49. So remember, division and multiplication, you can divide or you can multiply, that's fine. So 7 times 7 is 49, and the square root of 49 is 7. So essentially the square roots cancel each other out. And then for the numerator, square root of 2 times the square root of 7, 2 times 7 is 14. So now it's written and there's no radical in the denominator. For number 10, we have the square root of 49x squared, y to the 5th, z to the 9th, all divided by 25, a cubed, b to the 11th. And just so y'all know, I put this little tick on the end of my square roots just to show that's the end of it. I've had people ask me before. I can't remember when I started doing it, but now it's a habit. But anyways, so we have another division. So again, what you want to do is the square root of this whole thing is the square root of the numerator divided by the square root of the denominator. You can split it, that's fine. So I'm just going to simplify as we go here. So we've got square root of 49. So 7 times 7 is 49. So the square root of 49 is 7. So I've taken care of this one. The square root of x squared, 2 goes into 2 one time. So I've got an x out here. So I've taken care of that one. Y to the 5th, again, if it's an odd exponent, you can't, 2 does not go in an even number of times. It's not the perfect square. So you have to you can do y to the 4th times y. So 2 goes into 4 2 times, so I've got y squared, so I've taken care of that one, and then I'll have the y left. Z to the 9th, same thing. I can do z to the 8th times z, that is z to the 9th, and 2 goes into 8 4 times, so I've got z to the 4th, and that's gone. And then now what I've got left inside my radical is a y and a z. So I'm going to do the square root of yz, because remember, you can break these square roots up for division, that's fine. In the denominator, I've got the square root of 25a cubed b to the 11th. So the square root of 25 is 5. 5 times 5 is 25, so that's gone. A cubed, I'm going to do a squared times a. So the square root of a squared is just a. 2 goes into 2 one time. And then I'll have this a left, so I've taken care of that one. B to the 11th, I'm going to break it into b to the 10th times b. So 2 goes into 10 5 times, so the square root of b to the 10th is b to the 5th. So that's gone, so now all I've got left inside my radical is the square root of ab. And again, you do not want to keep radicals in the denominator. So to get rid of a radical, if it's just the radical of a product here like this, you're just going to multiply by the radical, and because whatever you do to the denominator, you have to do the numerator, so you're going to multiply it on the top and the bottom. And the reason you do that is because then you get the square root of ab times the square root of ab. This is the square root of ab squared, or a squared b squared, however you want to think about it, which is just ab. The square roots cancel. So I would have 7x y squared z to the 4th times the square root of yz ab, all divided by, you've got 5ab to the 5th times ab. I'll just rewrite it again. And so if I multiply my a times a and my b to the 5th times b, so my numerator doesn't change. Then I have 5a times a is a squared, b to the 5th times b is b to the 6th, and I'm done. So you just want to get rid of your radicals in your denominator, so rationalize your denominator. And so if you want to multiply, which we've kind of already been doing, I try to follow along with the reference text that's for free if you use it. So if you want to multiply, if you have the square root of a squared times the square root of a. So you can do that 2 ways. The square root of a squared is just a, so this is just a square root of a. That's fine. Or, so let me put an or here. If you multiply, a squared times a is a cubed. So you've got the square root of a cubed, which is still a square root of a. But it's just so you see, when you multiply, like I already mentioned, you cannot, you can multiply the inside, you just cannot do like, let me just write it down over here. Square root of a plus the square root of b is not the square root of ab. The square root of ab is the square root of a times the square root of b. Same's true for minus and division. So then for like number 15, you have the square root of x cubed times the square root of x to the 7th. So one option is simplify first and then multiply them together, but in this particular case, if you multiply them together, x cubed times x to the 7th, if you add those exponents, 7 plus 3 is 10. And then the square root of x to the 10th, 2 goes into 10 5 times, so it's x to the 5th. And again, because if you square x to the 5th, you get x to the 10th. So in some cases, you know, like this one, you could just simplify and you're done. In other cases, it's actually easier just to multiply them together and then simplify. If you have square root of 2, a to the 4th, times the square root of 5, a cubed times the square root of 2a to the 7th. Again, you could try to simplify these first, but I would multiply them all and then just simplify it one time. So 2 times 5 times 2, so 2 times 5 is 10, times 2 is 20, so you got the square root of 20. A to the 4th, a to the cube, a to the 3rd, and a to the 7th, so 4 plus 3 plus 7 is a to the 14th. Now you simplify that. So 20 you can simplify. So if you want to take the perfect square out of a number, you want to figure out what perfect square goes into that number. So for 20 it's 4. So 4 times 5 is 20. So the square root of 4 is 2. So I can get rid of that. The square root of a to the 14th, 2 goes into 14 7 times, so I can get rid of that. So I've got a to the 7th, and then all I've got left is the square root of 5. You can distribute radicals just like if it were an x out front instead, you can distribute them. So if we have the square root of x times the square root of x cubed minus the square root of 2x to the fourth. So again, I'm going to multiply and then I'll simplify. So if you want to distribute, you distribute square root of x times the square root of x cubed. That is the square root of x to the fourth. And then distribute here, minus the square root, 2 stays, and then x times x to the fourth is x to the fifth. So now simplify, the square root of x to the fourth is x, 2 goes into 4 2 times, minus x to the fifth, which we had up here was x to the fourth times x. So if it helps you to write that down, you can. 2 goes into 4 2 times, so x squared. And then you've gotten rid of this one, so you've got a 2 and an x left. And you're done. So going back to simplifying with radicals, simplifying with fractions, sorry. You have, for like number 22, you can do a couple of ways. So this one this one breaks it up into 2 radicals to start with. So you've got 75y to the 10th. The square root of that over the square root of 3y to the fourth. So the fastest way here, so before we were given 1 radical and I broke it into 2, so now we're given 2 radicals. The fastest thing to do here is actually to write it as 1 radical. Because you have the square root of 75y to the 10th divided by 3y to the fourth, because then 75 divided by 3 is 25. So you have the square root of 25. Y to the 10th divided by y to the fourth, 10 minus 4 is y to the sixth. And now take the square root of that. The square root of 25, 5 times 5 is 25, and 2 goes into 6 3 times, so 5y cubed. So in this particular problem, it's easier to combine the radicals, write it as 1 radical, simplify that fraction, and then do the radical. You can also do it, instead of me writing it down, I'll just show you over here. So I did it both ways. You can also do it by simplifying first. So 75 is 25 times 3, and then y to the 10th. So I've got 5 for the square root of 25, y to the 5th, and then the square root of 3 left. Down here, the square root of 3 I can't do anything with. I can take out the y squared for the square root of y to the fourth, so I've got y squared and the square root of 3. And then the square roots of 3 cancel each other out. And then I've got 5y over y squared, so or 5y to the 5th over y squared, so y to the 5th divided by y squared gives me the y cubed. So I still get the same answer, but I think it's easier on this particular one if you write it as 1 radical first. So for number 23 is also similar. You can split it up, or you can put it together, or simplify it separately. It's actually easier to just put it together and then simplify. So you've got the square root of 30p to the 5th q to the 14th over the square root of 5q to the 7th. So it's easiest to combine them and then simplify. And since I did that in the last one, I'll do it the other way this time. But I can show it to you in just a minute. So it's easier to combine them, but we'll do it the other way. So if I simplify first, to simplify, I can't do anything with 30. I can do something with p to the 5th. I can do, this is p to the 4th times p. So I've got p to the 4th and p. And then q to the 14th. So I've got, if I do 2 into 4, it's p squared. So this one's gone. Q to the 14th, I've got 2 into 14 gives me 7, so that's gone. And then I'm left with 30p inside there. And then in the denominator, I can do q to the 7th is q to the 6th times q. There is no perfect square in 5 for me to take out, so I can't do anything, so just have to leave it alone. So I can do the q to the 6th, so 2 into 6 is 3, so I've got q cubed times the square root of 5, so this is gone, I've got q left. And then going back to what we were doing before, where to get rid of the radical, you multiply the top and the bottom by the radical. Forgot I had my pink pen over here. You've got square root of 5q times the square root of 5q. And the reason you do that is because then they cancel each other out in the denominator. So you rationalize the denominator, you get rid of the radical. So then in the numerator, I would have p squared q to the 7th times the square root of 30p times 5. 30 times 5 is 150, and then pq. Divided by q cubed times square root of 5q times the square root of 5q is the square root of 5q squared, which is just 5q. So like I said, they cancel. So then I simplify this expression. So to do that, I've got p squared. I'm just going to carry that with me. 150 is 25. The perfect square in 150 is 25 times 6. So the square root of 25 is 5. So let me just write it this way. 5 times this, so this is gone. And then I've got the 6 pq left inside there. Divided by 5q to the 4th, because I multiply q cubed times q. Then what happens, these 5s, they cancel. Q to the 4th over q to the 7th over q to the 4th, 7 minus 4 is 3. So my final answer, finally, is p squared q cubed times the square root of 6pq. Now that was kind of the roundabout way to get there. It's fine, you can do it that way. But it would be easier if, to start with, you wrote it as one fraction, 30p to the 5th q to the 14th over 5q to the 7th, because then 30 divided by 5 is 6. P to the 5th just kind of hangs out, and then q to the 14th divided by q to the 7th is q to the 7. 14 minus 7 is 7. So I've got this, and then I simplify. I can pull out the p squared, I can pull out the q cubed, and I'm left with 6pq inside there. So it's easier in this case to do it that way. But you know, you can get there either way. So sometimes if you start one way, then you might decide another way was easier or whatever, or you can do it both ways and see if it works no matter what. That's always also good. And so if you want to rationalize the denominator, what happens if you have like an addition or a subtraction? So like for instance, -5 divided by the square root of 4, or not, divided by 4 plus the square root of 5. So how do you get rid of the radical if you have it as part of an addition or a subtraction? So then what you want to do is multiply by the conjugate. So the conjugate is you do the opposite sign. So if it's a plus, you multiply by the same thing with a minus. If it's a minus, you multiply by the same thing with a plus. And the reason that you do that is so let me write this here. -5, you can just leave the numerator alone. You don't necessarily have to, minus the square root of 5. You don't have to distribute. Divided by, now what's in your denominator? So what we do is, if you FOIL this, 4 times 4, so that's first 16. Then you've got 4 times the square root of 5 with a negative, so -4 square root of 5. And then this one's positive, square root of 5 times 4, so +4 square root of 5. And because see what happens here, these are going away, which is what we want. And that's why you do the opposite sign. It's called, you know, the conjugate, but that's why you make, if one's plus, you got to do the minus, or vice versa. And then you've got the square root of 5 times negative square root of 5 is minus the square root of 25, which is 5. Just like we were saying earlier, the square roots basically cancel each other out. So this goes away, and then all you're left with is 16 minus 5. 16 minus 5 is 11. And you're done. You've rationalized the denominator. What if you have, like number 26, you have 4 divided by the square root of 6 plus the square root of 2. So you cannot combine these because they're not both like square root of 6s or both square roots of 2s or whatever. They're not, remember, you can't combine them. It's not like multiplication and division. So you're going to multiply the numerator and the denominator by the conjugate, which is the opposite sign. So again, your numerator, you don't necessarily have to distribute. You can if you want to, but you know, as long as you just write it from a parenthesis, write it like that, that's fine. Divided by, down here, you've got first, square root of 6 times the square root of 6. Does the square root of 36 or just 6? Square root of 6 minus or square root of 6 times negative square root of 2 is minus the square root of 6 times 2 is 12. So when you're multiplying, you can combine them. If you don't want to do this, you can do minus square root of 6 square root of 2 with a dot in the middle, that's fine. And then you got square root of 2 times the square root of 6 with a plus, so 2 times 6 again is 12, so you got plus the square root of 12. And then square root of 2 times negative square root of 2 is minus the square root of 4, which is 2. So again, these are gone, and you've got left 6 minus 2. 6 minus 2 is 4. So these 4's actually cancel, so you're just left with the square root of 6 minus the square root of 2. It works the same if you have variables, no numbers, it's the same. You got the square root of a divided by the square root of a plus the square root of b. So again, you want to multiply by the conjugate, so it's the opposite sign, so we're going to multiply by the minus. If this was the minus, you'd multiply by the plus. And your numerator, you can leave this here, square root of a times the square root of a minus the square root of b. You don't have to distribute it. FOIL this, square root of a times the square root of a is a. Square root of a times negative square root of b is minus the square root of ab. Square root of b times square root of a is plus the square root of ab, or ba, it doesn't matter, the multiplication is commutative. Square root of b times negative square root of b is minus b. So again, these are gone, and you're left with a minus b, and you're done. So you're just rationalizing the denominator by multiplying by the conjugate. So just always make sure you do opposite sign. The biggest mistake on these is if this is a plus, you use plus here, but then it doesn't cancel, so they have to be opposites. So for the next part, you want to simplify by combining like terms. So for number 29, you've got 6 square root of 3a plus the square root of 3a. So I was telling you, you can't combine radicals, which is true. The only time you can combine them is if this part's the same. So your radicand has to be the same. So just like with variables, if it was an a and an a, you would say that's 7a. It's the same thing. If they're both the square root of 3a, you can combine them. So 6 plus 1 gives me 7 square root of 3a. Number 30, you've got 4 square root of 300 plus 2 square root of 500. So if I split this into perfect squares, 300, the perfect square in 300 is 100 times 3. And the perfect square in 500 is also 100. It's 100 times 5. So I would have 4 times square root of 100 is 10. That's gone, and I've got the square root of 3 left. Plus 2 times the square root of 100, again, is 10. And I've got the square root of 5 left. So I've got 4 times 10 is 40. The square root of 3 plus 2 times 10 is 20, square root of 5. Now the square root of 3 and the square root of 5 aren't the same, so I can't say that that's 60 square root of anything. So you just stop there. I could do a decimal form if I wanted to, but the point is to combine like terms. So the radicands have to be the same to combine them. So we'll just leave it alone, leave it like that. So 31, we have 2b times the square root of a cubed b to the 5th plus 6a times the square root of ab to the 7th. So as it is right now, I can't combine these because they're not like terms, but if I simplify them, maybe I can. So you want to simplify and then see if you can combine. So this 2b we'll just leave out there. 2b times square root of a cubed, so that's a squared times a. So I can take out an a, and I'll have a left in there. B to the 5th is b to the 4th times b. So 2 into 4 is 2, so I've got b squared. And then I'll have the b left. So all I've got left inside the radical is ab. So that's square root of AB. Plus the 6A, again, I'm just going to multiply it there. A, I can't do anything with. B to the 7th, I can do B to the 6th times B. So this is B, 2 goes into 6 3 times. So I've got B cubed, and then I've got left an A and a B. So the square root of AB. So if I simplify this, I've got 2AB times B squared is B cubed. So I've got 2AB cubed, and then the square root of AB. Plus, I've got 6AB cubed, the square root of AB. So now they do match. I've got AB cubed square root of AB, AB cubed square root of AB. So 2 plus 6 is 8. So it looked like to start with you weren't going to be able to simplify that, but if you simplify the radicals, then you actually can combine them. Number 32, we have 3by square root of 5y plus 4, 5 square root of 5b squared y cubed minus 2 square root of 5b squared y cubed. So right off the bat, I have square root of 5b squared y cubed, so I can go ahead and combine these. So I've got 4 minus 2, which is 2 square root of 5b squared y cubed. And then I still have this 3by square root of 5y stuck out here, plus that. So now I can't combine it the way it is, so if I simplify this, maybe I can. So I'm going to carry my 3by square root of 5y down here, plus 2 stays out front. B square root of 5 can't do anything with square root of b squared. I can take out and get the b. The y cubed is y squared times y, so I do the square root of y squared is y, and I've still got the y left, so I've got 5y in here. So now they're both by square root of 5y, which means I can add the coefficients. 3 plus 2 is 5, so I've got 5by square root of 5y. This last one here is like how we were doing conjugates with foiling, except it's not a conjugate, it's just 2 square root of 6 minus the square root of 3 times 3 square root of 6 plus 2 square root of 3. So you can FOIL all these just like we were doing. So just be careful, sometimes radicals get lost or something. So 2 times 3 for your first is 6, and the square root of 6 times the square root of 6 is the square root of 36 or 6. So you've got 6 times 6 to start with. Then you've got outer, so 2 square root of 6 times 2 square root of 3. So 2 times 2 is 4. And square root of 6 times the square root of 3 is the square root of 18. Then you've got inner, minus square root of 3 times 3 square root of 6. So I'm going to do it's negative. The 3 out front stays. Square root of 3 times the square root of 6. 3 times 6 is 18. And then negative square root of 3 times 2 square root of 3 is negative 2. Again, square root of 3 times the square root of 3 is 3. Then you can combine like terms. So I can combine these. So I've got 6 times 6 is 36. Oops. 36, not very good 6, but anyways. 4 square root of 18 minus 3 square root of 18 is just 1 square root of 18. And then 2 times 3 is 6. And then I can finish simplifying. I've got 36 minus 6 is 30. And then this is you always want to check if there's a perfect square in the number. And a perfect square in 18 is 9. 9 times 2. The square root of 9 is 3, and then I've got the square root of 2 left. So now I'm done. So these work just like our binomial times a binomial. When you do it with variables, it's the same thing. You just make sure you be careful with your radicals, and you don't lose the radical or anything. So the last thing we want to do is solve radical equations. And so since we're only doing square roots, basically to solve, we're going to try to get a radical equals another radical and square both sides and solve. Now the only thing is for these, you always want to check them, because anytime you're squaring both sides, when you square something it becomes positive or 0, but You have to be careful because sometimes you might square it and it's positive, and then you check it and it, doesn't actually work. So we've got square root of y equals 7. So if I square both sides, square root of y squared just goes away, and 7 squared is 49. Check that. Square root of 49 is 7. Check. If I have the square root of y is equal to -6. This cannot happen. Square roots cannot be negative, so this is no solution. Now, this is what I was saying though. If you don't pay attention to that and you square both sides, most people would write it this way, what happens is you get y equals 36, because -6 squared is 36. But then when you check it, is the square root of 36 -6? No, that's not true. So this cannot happen. So just be careful when you do these. Make sure you check your answers. If I have the square root of y minus 5 is equal to 5. So again, I'm going to just square both sides. So the square root of y to the 5th squared is just, or not y to the 5th, y minus 5. Square root of y minus 5 squared, I'll get it in a minute, is y minus 5. And 5 squared is 25. Add 5 to both sides, I get y is 30, which is fine as long as it works. So plug it in. 30 minus 5 is 25. Square root is 5. It does work. And I wrote it down on the notes if you look at it. If I have the square root, for this last one here, the square root of 5x plus 6 is equal to the square root of 3x plus 7. So again, I'm going to square both sides. So if I square both sides, the square roots go away. So I'm going to solve. I'm going to subtract 6 on both sides and move my 3x over to this side. So 5x minus 3x is 2x. 7 minus 6 is 1. Divide by 2. X is 1/2. And again, check it. When you check it, you should get the square root of 17/2 on both sides, which it does work. And I didn't start this very last one, but this one you have the square root of 12k minus 5 minus square root of 9k plus 10 equals 0. So you want to add this to both sides and then square both sides and solve, and it also works. So just make sure on your homework for these, you can, when you're solving, just make sure you check it at the end just to make sure you didn't miss a negative or something, so that the solution does work. And again, you can assume that they're all real solutions unless it asks you to tell what makes it a real solution. So if you have any questions or you want to see any other problems done, just send me a message.